Hi, my name is Donovan, Dr. Eric Donovan from the Department of Physics and Astronomy at the University of Calgary. I'm a space physicist, meaning I study the physics that goes on in the region of space right around the Earth. I'm told that Rex here has some questions for me. How can I increase my chances of seeing the Northern Lights? If you find yourself out late at night, like 11 o'clock or midnight, it's particularly if you're in the city's north. If you just look north and look along the horizon, if you see any green in the sky, that's almost invariably the Northern Lights. It's just good to go north. If it's on your bucket list, for instance, go to Yellowknife for a holiday. If it's clear, you will see the aurora. In Whitehorse, if it's clear, you will see the aurora. In Churchill, Manitoba. So going somewhere can increase your chances of seeing it. Looking up will certainly increase your chances of seeing it. And then if you're flying to Europe or flying to Asia, oftentimes the planes go far enough north that they cut through the auroral oval. I will often request to sit in a window on the left side of the plane going out, or on the right side of the plane coming back. And going there, I've often found myself looking at really beautiful auroral displays over Greenland, over northern Canada, over the North Atlantic. What is STEVE and how is it different from the Northern Lights? So STEVE, of course, is something that's really important to me personally. It stands for Strong Thermal Emission Velocity Enhancement. There were night sky enthusiasts who've been taking photographs of it for decades. They called it the proton arc, and it was an argument over that name that actually got me looking at what STEVE was, and it brought STEVE into the scientific community. That was back in around 2016. Proper aurora is caused by these particles coming down and hitting things and giving them energy. Whereas STEVE is caused by a very, very strong electric field in a very limited latitude range, which drives ions westward. So you get this river of very, very fast moving ionized gas, which might be going 10 kilometers per second. You lose this spectral lines, and what you have is a continual emission. So you take the entire atmosphere and you make it glow across a wide range of wavelengths. Thank you for watching. If you take one thing away from this video, it's that if you're interested in the Northern Lights, if you're outside at night, look up and make a habit of that.